Assalamu alaikum guys, I am Ghazanfar, your chemistry tutor, and today we are going to discuss about the Finkelstein reaction. Finkelstein reaction is an organic named reaction that resembles with the Swarts reaction. In Swarts reaction, there is formation of fluoroalkanes and fluoroarenes takes place when we treat the alkyl halides and the aryl halides with the metallic inorganic fluorides like silver fluoride, mercury fluoride, cobalt fluoride, and antimony fluoride in the presence of acetone. And the Swarts reaction also follows the SN2 mechanism. Similarly, the Finkelstein reaction is an organic named reaction. It is also a halogen exchange reaction. It is a halogen exchange reaction. Halogen exchange reaction, in which there is formation of iodoalkanes or iodoarenes when the alkyl halides or aryl halides are treated with sodium iodide in the presence of acetone, So what is Finkelstein reaction? It is a halogen exchange reaction in which there is formation of iodoalkanes or iodoarenes when our alkyl halides or aryl halides are treated with the sodium iodide in the presence of acetone. It follows SN2 mechanism. It follows bimolecular nucleophilic substitution mechanism, and there is inversion of configuration takes place. The configuration of reactants are totally different from the configuration of the products, and there is Walden inversion takes place. Walden inversion takes place in the Finkelstein reaction because the stereochemistry of the reactants and the products become changed, and the Walden inversion is the inversion of the configuration of the chiral center during the SN2 reaction. And 3-degree alkyl halides, 3-degree alkyl halides and 3-degree aryl halides does not give a good yield in Finkelstein reaction due to the steric repulsion between the bulky groups. 3-degree aryl halides and alkyl halides does not give a good yield in Finkelstein reaction due to the steric repulsion between the bulky alkyl and bulky aryl groups. So there is a steric repulsion present between the bulky groups. And Walden inversion takes place in the Finkelstein reaction. So we have an alkyl halide. Reaction takes place in the presence of sodium iodide and acetone. There is formation of alkyl iodide and sodium halide precipitates. Why we use acetone in this reaction? Because there is a repulsion between the chloride ion and the negatively charged oxygen of the acetone. That's why we use acetone in the Finkelstein reaction. Mechanism of this reaction. We have sodium iodide. Sodium iodide gives sodium ions and iodide ions. This iodide ion acts as a nucleophile. It attacks from the back side of the leaving group. Leaving group leaves and there is formation of iodoalkane. This sodium ion and this halide ion react to give sodium halide. So this is the SN2 mechanism of Finkelstein reaction in which there is inversion of configuration takes place. Examples. For example, we have halo. Suppose we have alkyl halide and sodium iodide gives sodium ions and iodide ion. This iodide acts as a nucleophile, attacks from the back side. Chloride ion eliminated, and there is Walden inversion takes place. Walden inversion takes place, follows SN2 mechanism, and there is a formation of iodoalkane. There is formation of iodoalkane. We have another example, like we have aryl halide and this iodide. Again, sodium iodide gives sodium ion and iodide ion. This iodide ion acts as a nucleophile, attacks from back side of the leaving group at the electrophilic center. Leaving group leaves. Walden inversion takes place. Walden inversion takes place, follows SN2 mechanism. Reaction takes place in the presence of acetone, and there is formation of iodoarene. There is formation of iodoarene. The stereochemistry of this chiral center is different from the stereochemistry of this chiral center. So due to the inversion of the configuration of chiral centers during the SN2 reaction, this is called Walden inversion. We have another example, like we have a methyl group here, chloride here, hydrogen here, methyl group here. So the iodide ion, sodium iodide gives sodium ions and iodide ion. This iodide ion attacks from the back side. Chloride ion eliminated, follows SN2 mechanism. Reaction takes place in the presence of acetone, and Walden inversion takes place. Walden inversion takes place. There is change in the stereochemistry of the reactants and products, and there is formation of this product. So what is the stereochemistry of the chiral centers? According to the Canning-Gold period rule, this gets number 1 purity, it gets number 2 purity, it gets number 3 purity. The rotation is clockwise. The rotation is clockwise, so this chiral center has R configuration, and the configuration of this chiral center, it gets number 1, it gets number 2, it gets number 3 purity. The rotation is anti-clockwise, so the configuration of this chiral center is S configuration. This chiral center has R configuration. So configuration of reactants and products are inverse. So stereochemistry of reactants changed. That's why it is a Walden inversion. This is all about the Finkelstein reaction.